Hey there, students. In this clip, we're going to learn how to derive the parent sine and cosine functions, the graphs of the parent sine and cosine functions from the unit circle. So write down the title, deriving the parent sine and cosine graphs from the unit circle. Okay? Write that down. Now to get this started, you're going to need to draw a circle and some lines. Okay? So write down the title, deriving the parent sine and cosine graphs from the unit circle. Now this is what we're going to need. We're going to need a unit circle, as illustrated here, and a bunch of lines. Alright, this will be your y-axis for the unit circle. This is going to be the y-axis for your graph, but there's an overlap for the x-axis for both of them. So one x-axis will suffice. Alright, now we're going to put in our points due to our reference angles. We don't have three reference angles, right? We have the 30-degree reference angle, so put a point there. That's going to be our 30 degrees. We'll put 30 degrees here. And then the next one will be a 45-degree angle, 45 degrees there. And then the last but not the least is your 60 degrees. Alright, I'll put that one there. And we know we start from um, 0 degrees, right? So we have 30, 45, 60. And then the last one is 90 degrees. Let's put 90 over here. Okay? So we have the 4 going up. We can put the 4 going down. 1, 2, 3, and that. And then from here, tracing the right across, we have a point here. Here, then we'll have another point here. So these are the points on your unit circle, okay? You can put in the angular values just by looking at a unit circle, or you can do the calculations to determine what the values of these angles are. Alright? So 30, 45, 60, and then this is 180. Let's draw a note, let's put it inside. 180. This right here is 270. And then 0 is also 360. And then we can figure out what these angles are. This one you back up by 30 degrees to 150. You back up by another 15 degrees to give you 135. And then you back up 60 degrees to give you 120. Alright? And then you can calculate what these other angles are. Now, remember when you're doing your unit circle, you always have to have this pattern going. 0, 1/2, root 2 over 2, root 3 over 2, and then 1. This pattern always shows up on the unit circle. Remember that, right? We're going to use that here. So we start from the origin on the x-axis, since the radius is 1. This is going to be 1 on the x, 0 on the y. And then when you get all the way here, it's going to be, it's going to reverse, right? 0 on the x, 1 on the y. So what are all these coordinates here going to be? This one is going to be 1 after, well, let's do the 0 part. So 0 is going to be, after 0 is 1/2, right? So 0 is 1/2. And before 1 is root 3 over 2. So 1/2 here, and then root 3 over 2 there. Okay? Root 3 over 2. I'm going to write that bigger so you can see. It's going to be root 3 over 2 and 1/2. And 1/2. If you can't see this, you can look at the unit circle, okay? And then, after 1/2, what do you have? 0, 1/2, 0, 1/2, and what is that? Root 2 over 2. Remember the pattern for your unit circle, root 2 over 2 always repeats root 2 over 2 both sides. And then this one is going to be 0, 1 half, and then 1 half, and then for the 1, half before 1 is root 3 over 2. So you see the pattern? We have 0, 1 half, root 3 over 2, root 3 over 2, and then 1. And then 0, 1 half, root 2 over 2, root 3 over 2, and then 1. This pattern keeps going both directions on the x and on the y. And you have the same thing here too. So when you're calibrating this, you see this dot right here, I'm going to trace it right to here, mark that. And then the other one, trace it right to here. And then that one, trace it right to here. Okay? So what are our calibrations for this axis? And then so let's see. Well, we have one here too. So have something like this. So what are our calibrations going to be? This is going to be starting from 0. We're going to put exactly the same story here. Again, 0, what's after 0? 1 half, right? 0, 1 half, root 2 over 2. This is going to be root 3 over 2. It's going to be hard to fit. And then this is going to be 1. This is 1. And then this right here is going to be root 3 over 2. So root 3 over 2, of course again. Alright, so this goes to this goes to that goes to that, and that goes to that. Now what am I going to put on my x-axis? See these angles here? That's what is going to go on my x-axis. So I'm going to use 2 boxes. So we're going to go 1, 2 is 30. 1, 2 is 45. 1, 2, 60. 1, 2, 90. Where did I get this from? These are my angles over here. So we put the coordinates on the y, and we put the x's on the, we put the angles on the x. So what we're doing is we're kind of unraveling the unit circle to see what we generate. Okay? Now let's graph the points. Remember, let's graph y. We're gonna try to graph y equals sine x in this case. So remember, sine is your y coordinate, right? Is a y coordinate. Sine is a y coordinate. So what I'm going to be graphing is simply the y coordinate components. So let's graph the y coordinate points. So on these points I have here, all I care about is just the y's. So starting from 0, when the angle is 0, the y coordinate is 0. So 0, 0. Anyway, put the point here. 30 degrees, the y coordinate goes up to 1 half. 45 degrees, the y coordinate goes up to root 2 over 2. 60 degrees, the y coordinate goes up to root 3 over 2. 90 degrees, the y coordinate goes up to 1. So we have the first quadrant. Now, what are these quadrants right here? What's going to be here? This is 1, 0. This is going to be negative 1, 0, right? And then these points, we know that in this area, our x coordinate is negative and the y coordinate is positive, right? So it's going to be exactly these points, only that the x's are going to be negative. So it's identical to this, only that the x's are going to be negative, all right? So over here, you're going to have negative root 3 over 2 comma 1 half, just like this. And then this one is going to be negative root 2 over 2 comma root 2 over 2. And then for this one, is going to be 1 half comma root 3 over 2. Remember, if you can't see this, that's fine. Just look at the unit circles, exactly the same thing. I'm copying this right off of the unit circle. Alright? Now, we're going to put the angles here. After 90, we have 120, right? So after 90, we have 120. And then after 120, we have 135. 135. And then after 135, we have 150. And after 150, we have 180. Okay? And we can keep going like that. On and on and on. Let's do this one. Okay. So let's do this. So guess what? The y-axis are going to be the same, but the only difference is that the x-axis are going to be negative. So let's graph it. So for 120 degrees, we need just the y, which is root 3 over 2. So the 120 is going to go right here. For 135, we just need the y coordinate, which is root 2 over 2, which goes right here. For 150, we need just the y coordinate, which is 1/2, which goes right here. And then for 180, we just need 0, which goes right here. So you see what we just formed? A nice little arc for the first quadrant. Okay? Now what do you think is going to happen here? It's going to be exactly the same thing, but it's going to go in the opposite. It's going to go in the opposite direction. So from this right here, we can extrapolate what this pattern is going to be. So down here, you can make a guess that it's going to be over here. This one, you can guess that it's going to be over here. This one down here is going to be over here. And then the lowest point is going to be here. And then the pattern reverses itself. Every two you go to there, and then up there. So that's how the pattern basically repeats itself. So this is your sine curve on the positive side. Now just to illustrate the connection, you can do this. See from here, traces perfectly to there. Boom. And it also traces straight to there, like that. And then from 45, it traces perfectly to there, and it also traces to there. And then for your y, it traces perfectly to there, and it also traces to there. And then for your 90, it traces perfectly to there, and that's it. And then these points trace down to your y-axis, like this, like this, like this, like that, and then like that, and then like that. Okay, so there goes your sine graph right there. And then if you look at the other side, the same thing happens. Okay, you have the same thing happening here. This point traces perfectly to there. This point traces perfectly to there. This point traces. This point traces perfectly to there. This point traces perfectly to there also. Alright, where's our sine graph? Let me put in the sine graph before I finish. So the sine graph is going to be the connection of these dots right here. So we're going to go like something. We're going to go something like this. Straight like that. Like that. Like that. Can you see that? Yeah. Like that. Okay, so this right here is the sine graph. You see how it's coming like a wave? Just by following the y coordinates around this circle, you're just going to be having a wave going up and down and up and down and up and down. And then we notice that this one can trace to here, this traces to here, that traces to there, that traces to there, that traces to there. So basically the pattern continues forever. Okay? So they have a sine curve. It's just the y coordinate of a unit circle we generate this way right here. Okay? So that's basically that. Now how about the cosine business? Cosine business is very similar. The only difference is where do we start? Okay? So let's try the same thing for the cosine business. So we're going to graph y equals cosine x. Same story. Let's put the points in first. We know we have 3 points in the center for our unit circle. So we'll start with this one. That's the 0 degree one. And then the 30 degrees. 30 here. What do I put? See where that puts. So you can put 45 here. This is not perfect, it's just a sketch. And then 60 there. So this is 45. And then this is 60. And over there you have your 90 degrees. 90 degrees. Okay? This line needs to be perfectly centered. Okay. Alright, and then you put your dots on the other one. Put a dot over here. Put a dot here for 45. Put a dot here for a 30 degree reference. Put another dot here. And then going down, you have a dot here, here, another one here, another one here, and then put one here, one here. All we're just doing is trying to put 3 dots in between each quadrant, just like you have in a unit circle, and then you have that there and that there, okay? So we know this is yeah, let's put it inside. This is 180, this is 150, just like before, 135, 120. Now, this is our y-axis for the unit circle, y-axis, I do not like this y-axis, because it is skewed. That's the y-axis for the graph, and they will have the same x-axis. Okay? So let's put our coordinates in here. So the coordinates for this one is 1 for the x, 0 for the y. And then this one is going to be 1, before 1 is root 3 over 2. Root 3 over 2 and 1/2. And then you're going to have root 2 over 2 for both. And then this one is going to be 1/2. And then root 3 over 2. And then this is going to be 0, 1. Remember, we're following this continuum. 1, 1/2, root 2 over 2, root 3 over 2, 1. You always follow this pattern, okay? Alright, so we're going to go mark this from here. Mark this one, 45, this one, and then that one. So basically what we have is this side is 1/2, this is root 2 over 2, this is root 3 over 2, and this is 1. And then our angles, same business, 30, because this is 0. We're going to angles here, 30, 45, 60, 90. Okay? So, let's do the other one. So, after 90, we have 120, 135, 150, and 180. Alright, so now let's sketch the graph. Remember, cosine is your x-coordinate, right? Is your x-coordinate. So we're going to be graphing the x-coordinates on this line right here and see what pattern we generate. Okay, so for the x-coordinate, starting from 0, the x-coordinate is 1. So instead of starting from here, we're going to start from up here. So do not forget, cosine always starts from 1. Cosine starts from 1, and sine starts from 0. That's the difference. Okay, like a phase shift. 1, and then this one, we're just looking at just the x-coordinates. So it goes from 0, 1. Next one is root 3 over 2, drops down here. Next one is root 2 over 2, drops down here. For 60 degrees, it's 1/2, drops down here. For 90 degrees, it's 0, all the way there. Boom. For 120, we're going to have the same thing going on, but in this case, you notice what will happen. What will happen? Well, let's see. This is 1/2, root 2 over 2 is going to be the same thing here, but the x is going to be negative. It's going to be negative 1/2, root 3 over 2. Look at a unit circle for confirmation. And this is going to be negative 1/2, negative root 2 over 2, negative root 2 over 2, no, the first one is positive. So it's going to be just negative root 2 over 2, and root 2 over 2. Sorry about this poor writing. And then the last one is that one's going to be negative root 3 over 2 and 1/2. And then this is going to be negative 1, comma 0. So what's happening here? All the x's are now negative. So it's going to be the same story here, but you're going to have negation on the x component. So we're going to go underwater here. So this is going to be negative 1/2. That's opposite of that. And then this one is going to be negative root 2 over 2. And then this one is going to be negative root 3 over 2. And this one is going to be negative 1. Put in the points. 90, 120 is negative 1/2. You see the pattern? 135 is negative 2 over 2, right here. 150 is going to be negative 3 over 2. And 180 is negative 1. Yes. And then we can just follow the pattern and complete the cycle without even knowing what the coordinates are. Just use symmetry to complete it. So we know for sure that this next point is going to curve right back here. It's going to curve here. And the next one is going to go here. And the next one is going to go right here. And the next one is going to go right here. And the pattern continues. Wrong point. And the pattern continues. Okay, so that one goes. Where am I erasing? That one is going to go up right here. Okay, so let's connect the dots to generate our cosine graph. So our cosine graph is going to curve like this, connecting that dot. Try it as best as you can. To there, 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 boom. And there goes your cosine curve. Alright, so it's very similar to the sine graph, only that it's starting from a different place, if you notice. Very similar. It's from that wave pattern just like this, only that it's starting from 1. Okay, so now you connect the dots. You can just like this. Let's show the connection. This doesn't apply here.